Hi class, welcome to week 5. I hope you're doing okay getting your proctored exam set up and taken. I know there can be some confusion, so be sure to check the OTC website. I think they have everything laid out very well for you. Let me know if you're going to run into some sort of problem. But otherwise, let's get started with week 5. We're looking at how to code methods and some other great things. There are some Rebel courses for you. I'm going to take a quick look. I created a page with those links so they wouldn't be buried. Remember, you can always just go straight to rebel.it and see all of your courses. The links are just a one-time invite. Once you've accepted the course, it'll show up on your course page, your student page. There is some additional practice for some looping. Please go through that. You'll find those very quick and informational. And some new Rebel practices for creating methods, which is this week's topic. Besides the Rebel courses, you'll see a link to these videos and your assignment for the week and quiz for the week. So everything should be there for you. Now this week, again, like I said, we'll be looking at coding methods. And what are methods? Well, that's Java's name for any sort of module or subprogram. You might have heard them referred to as functions or subroutines, maybe procedures, but for Java, they're all methods. So a method is just a logical chunk of code that is defined and can be executed. So we can run a method from another method. We use methods to separate functional tasks in a program. We use methods to eliminate redundant code, and methods help us implement a modular, maintainable programming style, which is important as a programmer. You should remember the hierarchy chart from your intro to programming days. Normally, we like to see a nice modular approach, like a main module that calls an input module, a process module, maybe an output module. Now we're going to see a lot of varieties in this hierarchy chart. This is by no means a rule. It's just a good example of what we would see. Now we've been working so far with our main methods in Java. We're going to expand that a little bit to branch out and have a little bit more modular approach to our programs. Start thinking about those hierarchy charts and how we want our program's hierarchy to be established. We always want to make sure that we're eliminating duplicate code. Anytime we see redundancy in our code, we should be examining that code to try to figure out how we could combine it into a module so that we could make it a more functional approach to solving this problem at hand so that we wouldn't have all this redundancy and duplication. Bad stuff. So a method is like some things. You could think of it as the chorus to a song, like something that could be repeated over and over. It could be a recipe that you use over and over, and you hope that you can do it the same way each time. Kind of like doing the laundry. You might get clean clothes, you might not. But that's what a method is like, a finite task that we can do repeatedly or that has a logical function. So with the Java method, we are going to code, first of all, a method header, and then we'll include a method body, and then the method closing. The method header starts with the modifier, the access modifier, which we've seen as public or private. In this case, we have a return type. Our modifier also includes the keyword static here, which says that this method will only be loaded into memory one time, which will make more sense as we work with other kinds of objects. Next, we have our return type, which in this method is set to void, which means this method will not return any data. There won't be any output from this method. Then we have the method name, which in this case is my method. Inside parentheses after the method name, we have a list of parameters. In this case, our method only accepts one parameter, and it's data type double, and we're going to call that variable my variable within our method. That's what that variable will be named. So if we look at a Java method, it's a lot like the print line command. We have the ability to call that method from wherever we are. We created our method, my method, and then we're going to have some code inside the method and end it with a closing curly brace. Now here's some code. In this code, we have a main method, which we'll come right back to, and then we've declared our new method, my method, and we've said our method indicates an input of a double named my variable. Our method does not return any data. It has no output. It says void. Now in our method, all we do is print out this message. The variable is, and then my variable, which is the data that was passed to us as input. In this example, our main method calls our my method method. You see that connection? It's calling it. And when it calls it, it places the data that it wants to pass to it within the parentheses. So the parentheses match up with the variable declarations in the method header. So my 7.5 becomes the value of this double variable, my variable. So when I issue the print line statement, my output is, the variable is 7.5. So we have all those things connecting with each other. Now sometimes our method will have output. It will return a value. In this case, we're going to update our method named my method. It's still going to accept a double as input, but now it's going to return an integer value as output. We start out our method header again with the modifier, public static. The return type is changed here to int for integer. Our method name stays the same, and our parameter list is the same. We only want one variable to be passed to our method as input as a parameter. Now in this method, we do return a value. So in our declaration, again, we have that keyword int, which says this is the data type of the value I'm going to return. Now this method just returns a hard-coded 0, and that's it, and the method ends with a closing curly brace. So when we return a value from our method, we're going to use the return keyword. And in the return statement, we're going to specify what data to return back to our caller. This could be a literal, like the number 5. It could be a variable, but we can only return one thing. In this example, we have a main method that sets up a variable as an integer. The variable is named return variable, and we set its value by calling the method named my method. We're passing the method named my method the value 7.5 as a parameter. Then we're issuing a print line statement saying the return value is, and whatever the value is of our return variable. You could set this code up in NetBeans if you wanted to try it so that you can see exactly how it works. Now our my method is declared with a standard method header, public static, because it's a static method called by a static method, our main, and it returns an integer variable. Our method is named my method and expects a double parameter. Now our method is going to print out the string the variable is, and then the value of our variable, and then it's going to return our variable multiplied by 2, and it's going to cast that as an integer to make sure that it's returned as an integer, because we said we were going to return an integer. From that, we receive this output. We may want more than one piece of data as input to our method, so we can specify multiple items in our parameter list. We just have a comma in between each of the different parameters. For each parameter, we specify the data type of the parameter and the parameter's name for within our method. Whenever another method calls our method, it will be passing values to us, which can be considered arguments that are being passed to our method as parameters. This method header becomes the method signature. The signature of the method includes the name of the method, parameter types of the method, and return types of the method. In this way, we can make sure that we're calling the correct method when we're using a call in Java. We can actually overload methods, which is the beginning of object-oriented programming. By overloading methods, we can create one method that has the same name, but it has multiple different signatures. So in this example, we have 3 instances of the method. The first instance returns an integer value as output. It expects as input a double value and an integer value. The second instance returns an integer value, but it expects as input a string. And the third instance returns a string and expects as input a double and an integer. So now, depending on how we call this method, Java and its runtime system will determine which instance of the method to run. So if we call our my method expecting a resulting string, passing a parameter of a double and an integer, our orange version here will be the one that gets executed. Overloading methods is something that's really great, and we'll talk about it a lot more. Something for you to think about to come. So in summary, Java implements functions and subroutines, all different types of subprograms as methods. A method has a unique signature that's developed from its header. A method header specifies the input required by the method in the form of parameters. A method header specifies the data type of the return value output by the method. And a method contains a body of code. A method code body is enclosed by curly braces. So you'll definitely want to take a look at the Rebel exercises, and we'll be trying to get some more videos out to you as soon as possible. So hope you have a great week, and let me know if you have any questions. Thank you.